Electrical engineering is like magic, but it's real. It's the study of electricity and how we can use it to power our world. From the tiny circuits in your phone to the massive power grids that light up cities, electrical engineering is everywhere. It's a field full of exciting discoveries and innovations that shape our lives in countless ways. In this essay, we'll explore some simple yet fascinating electrical engineering experiments that you can try at home. These experiments will introduce you to the basic principles of electricity and spark your curiosity about this amazing field. Let's start with the most basic element of electrical engineering, the circuit. A circuit is a closed loop that allows electricity to flow. In this experiment, we'll create a simple circuit to light up a bulb. Materials you'll need: a battery, 1.5 volts or similar, a light bulb, small low voltage, 2 pieces of insulated wire, about 6 inches each, wire stripper, optional, for easier wire stripping. Steps: 1. Carefully strip about ½ inch of insulation from both ends of each wire. 2. Connect one end of the first wire to the positive terminal of the battery. 3. Connect the other end of the first wire to one side of the light bulb's metal contact. 4. Connect one end of the second wire to the negative terminal of the battery. 5. Connect the other end of the second wire to the remaining side of the light bulb's metal contact. What happens? The bulb lights up. This is because the battery provides the electrical energy, which flows through the wires and the bulb, causing it to light up. Batteries are like tiny powerhouses that store chemical energy and convert it into electrical energy. In this experiment, we'll build our own battery using simple household materials. Materials you'll need: a lemon or potato, a copper coin, a galvanized nail, coated with zinc, a voltmeter, optional to measure voltage. Steps: 1. Roll the lemon on a hard surface to soften it and release its juices. 2. Insert the copper coin into one side of the lemon. 3. Insert the galvanized nail into the opposite side of the lemon. 4. If you have a voltmeter, connect the probes to the coin and the nail. You should see a small voltage reading. What happens? The lemon acts as an electrolyte, and the copper and zinc act as electrodes. Chemical reactions between these materials create a small flow of electrons, generating a small voltage. Electricity and magnetism are closely related. When electricity flows through a wire, it creates a magnetic field around it. In this experiment, we'll use this principle to make our own electromagnet. Materials you'll need: a battery, 1.5 volts or similar, a long piece of insulated wire about 3 feet, a large iron nail, small paper clips or iron filings. Steps: 1. Carefully strip about 1 inch of insulation from both ends of the wire. 2. Wrap the wire tightly around the nail, leaving about 6 inches of wire free on each end. 3. Connect one end of the wire to the positive terminal of the battery. 4. Connect the other end of the wire to the negative terminal of the battery. 5. Hold the nail near the paper clips or iron filings. What happens? The nail becomes magnetized and attracts the paper clips or iron filings. This is because the flowing electricity through the wire creates a magnetic field that magnetizes the nail. Section 5. Experiment 4. The fruit battery, nature's power source. Similar to the lemon battery, we can use other fruits and vegetables to create a battery. Different types of fruits have different electrolyte properties, resulting in varying voltage outputs. Materials you'll need: various fruits like oranges, apples or tomatoes, copper coins, galvanized nails, and a voltmeter. Steps: insert a copper coin and a galvanized nail into each fruit, keeping them apart. Use the voltmeter to measure the voltage between the coin and nail in each fruit. What happens? You'll observe different voltage readings for different fruits. This demonstrates the varying electrochemical properties of different fruits. Section 6. Experiment 5. Dancing salt and pepper. Static electricity at play. Static electricity is the buildup of electric charge on a surface. This experiment shows how static electricity can create attractive forces. Materials you'll need: a plastic comb or balloon, a plate. Pepper steps: 1. Spread a thin layer of salt and pepper on the plate. 1. Rub the comb or balloon vigorously on your hair or a woolen cloth. 1. Hold the comb or balloon close to the salt and pepper mixture. What happens? The pepper particles will jump towards the comb or balloon. This is because the static charge on the comb attracts the lighter pepper particles more strongly than the salt particles. Section 7. The importance of understanding basic principles. These simple experiments demonstrate fundamental principles of electricity and magnetism that form the basis of electrical engineering. Understanding these principles is crucial for designing and building electrical circuits and devices, troubleshooting electrical problems, innovating and developing new technologies. Section 8. Safety first. Always experiment responsibly. While these experiments are safe when done correctly, always prioritize safety when working with electricity. Never experiment with high-voltage sources like wall outlets. Always use insulated tools and wires. Supervise children and ensure they understand the safety precautions. Section 9. Conclusion. Keep exploring the world of electricity. These experiments are just a glimpse into the fascinating world of electrical engineering. There are countless other experiments and projects you can explore to deepen your understanding and spark your passion for this field. So keep experimenting, keep learning, and who knows, you might be the next great electrical engineer.